Hello and welcome to this lesson about ratios and rates. The learning target for this video is writing and comparing ratios and rates. So first, let's talk about what a ratio is. A ratio is comparing two numbers. And what we can do is we can compare it in three different ways. So we could use words to say something like we have 2 to 3, where we're comparing the numbers 2 and 3, and they're usually associated with something. So it could be like, in a class, the ratio of boys to girls is 2 to 3. We could use a colon, 2 colon 3, or we could use a fraction. And this is the form that tends to get used a lot in math, where we say 2 over 3. And so those are the three ways that you can write out a comparison of two numbers that make up a ratio. Then, when it comes to ratios, we have two different types of ratios. So, two types of ratios. The first one is what we call part to part. And then the second one is part to whole. So part to part, think about recess. And when you're playing a game and you have an odd number of people, and you're like, hey, this ain't fair. It's 4 to 5. It's 4 on 5. Well, you're comparing parts of something. So in this case, it's a team. The part of my team versus the part on your team. But part versus whole, this is pretty much, grades. So when you do something on a quiz or a test, so let's say you get 9 out of 10, the 9 is the part that you got, but the 10 represents the whole. And so what I want to do is, got to undo that line there. What I want to do is show you some examples of this. So let's just say here we have a couple of different, tokens, balls, whatever you want to call them. We got a couple blue ones in here. We got a couple of red ones in here. And then we got a couple of green ones in here. All right, so when it comes to ratios, to show you what a part to part is, let's go the ratio of blue to green. Now, the position of the ratio matters a lot. So I have blue in the numerator and green in the denominator. Or if I were to write this as like a colon, it would be blue colon green. And when we see it as a fraction, it's really important that, we see the importance of the positioning of the numbers. So, if we take a look at it, we have 1, 2, 3 blues over 1, 2, 3, 4 greens. And we could also write it as 3 to 4 like that. And seeing it as a fraction shows that, the positioning matters, because 3 over 4 does not equal 4 over 3. And so we just have to be mindful of ratios as we're writing them. What are we being asked to do, and in what order are we being asked to do? Now this was part to part. Now let's do part to whole. So to do that, I have to figure out how many there are total. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's going to be my denominator, and that's not going to change regardless of what part I pick. So if I want red to whole, or if I went blue to whole, or even green to whole, that denominator is always going to be 10 because there are 10 pieces. And so let's just say we're going with red. That's going to be 3 over 10. And so I've now written a ratio from part to whole. But if I picked something like, let's say, green, how many are green out of all of them? Then I end up getting 4 over 10. And this leads to our next concept, which is an equivalent ratio. Oops, that's not how you spell equivalent. Equivalent ratios. These are ratios that have the same value. And so what we tend to get is something like, if we have 10 of something, and if we had an even number of a part, we could reduce that. So 4 over 10 is equal to 2 over 5. But then let's just say, what if there were 30 of these balls in this thing? Then we would have, and maintain that ratio of 2 to 5. So, 2/5 of it were going to be green. Well, how do we get from 2/5 to 30? We got to ask, since they're equivalent, what am I multiplying this by? And that would be 6. And so since it's equivalent, I have to multiply this one by 6 as well. And that gives me 12 out of 30. And so again, equivalent ratios are ratios that have the same value. And sometimes we need to use equivalent ratios to help us compare ratios or rates. So a rate is a special kind of ratio. And what this is it's comparing two different units. So the best example of a rate would be speed, because that's in miles per hour. How fast you're going, or how long of a distance you're going in a certain amount of time. Now, something that's not a rate would be, so let's put not a rate, would be boys to girls. And even though there are differences between boys and girls, they still fall in that category of, these are all humans. These are people. These are the same thing. Or if you're comparing green marbles to red marbles, they're the same thing. And so they're not a rate, because a rate, we're comparing two different units. Like a mile, which is a measure of distance, of physical distance, and this is a measure of time. And those are two very different things. Now, as I was saying, one thing that we love to do in math is we love to compare rates. Which one's going faster? Which one's going slower? Depending on sort of the situation, the question can be framed different ways to kind of get to see what's going on with two different rates. And so what I want to do is talk about how we do that. And essentially, the way we compare rates is we have to make equivalent ratios. That's how we have to do it. And we have two options. And they are to either build up or break down. Let me show you what I mean by that. Let's say we have two people, person A, and over here we have person B. And they're both reading a book. And they're reading the same book. And we're given some rates about how fast they're reading. And person A can read 9 pages in 4 minutes. Person B can read 11 pages in 5 minutes. Who is the faster reader? Faster reader. Well, we again have two options. We can build them up or we can break them down. So if we were to, let's say we build them up, we're going to need to find a common denominator here. And so the common denominator between 4 and 5 is 20. So what I would need to do is multiply both by 5, or this one by 5 over 5, the numerator and denominator, and that would give me 45 pages over 20 minutes. And then this one, I'd times by, not 5, but 4 over 4. And so that would give me 44 pages over 20 minutes. And so the faster reader would actually be A. Now, that's if we build up. But what if we break it down? Oops. If we were to break it down. And if we were to break it down, what we end up getting is something that's called a unit rate. And that boils down to or what that means is you have a denominator of 1. And so what we do is we take a look at this and we literally do the raw division. we go 9 divided by 4, which is going to be 2.25 over 1. So that's 2.25 pages per 1 minute. And since we have a denominator of 1, this is the unit rate. Do the same thing here. 11 divided by 5 is 2.2. That would be pages per 1 minute. Normally, when we're dealing with fractions and our denominator is 1, we don't write it. But in this case, we do, because we're curious to see what's going on there. And we want that 1 there to let us know that this is truly a unit rate. And so when we break it down to a unit rate, we can see that still person A is reading faster, because for every minute they're reading 500th more of a page than person B. And so that's sort of what we're going to do with ratios and rates. First, we need to write them. Second, we're going to do a lot of comparing of them. And when you compare them, we have a couple of options. You could either build up, which is what I did here with going into a common denominator of 20, not 20 pages, but 20 minutes right here, and figuring out from there. Or we can break it down to a unit rate and see what gets done in 1 minute, 1 hour, 1 whatever, to see who is going faster. So good luck with your homework and practice, and let me know if you have any questions.